Okay, so I'm not going to require a graphing calculator. I believe in the syllabus it says you should be using this guy. You can also check them out at the math department. It's like when I bought this, it was like $10, but I'm sure nowadays it's probably like $20. The TI-36 Pro has the functions for matrices. We hit second math. Oh, let me turn it on. It has matrices up to 3 dimensions. So it can handle systems of 2x2s, which we'll talk about in the future. If you have one of these, like the TI 83s or 84s, it can handle matrices of and system of equations and matrices of dimension. Yeah, hit on. So here you can choose the dimension. So 10 by 10 or whatever. Anyway, so either of these calculators work. If you have some Casio, I'm sure they do something similar, but I'm not familiar with those guys, so I can't help you with them. But 84, 83, 36, if you need any help with that, um, it'll help you out. There's also some really easy solvers that you can use online, but for exams, you can't really use those. But I'll show you them for homework. Okay. But anyway, let's get to this idea. 9.1 is about solving a system of equations. So solving a system basically is just figuring out, like, graphically what it means is you're finding the location or the point of where two lines intersect. So when you're solving a system, there'll be 3 scenarios. So first scenario, we're solving a system is a unique solution, meaning a single point, a single location. Okay. Visually, it would look like this. You have some graph, some line going this way, some line going that way. They intersect somewhere. This point here is the solution to the system. All right. Scenario 2. Wrote that all stupid. Second scenario. Let me see the proper for solving a system is a, oh, by the way, this is also called consistent system. So second scenario for solving a system is basically having no solution. This is called a inconsistent system. Okay. it looks like this. Basically, you have two lines that are parallel and they never intersect. So you have a line going this way, line going that way. No solution. Okay, last scenario. We're solving again. This is assuming you're doing a two-dimensional problem, two equations, two unknowns, but this scales up to n dimensions. Doesn't matter.
I guess it's not a solution because of the vertical line.
It's not a solution because they're both parallel and they never intersect. So as they go on forever, they'll never touch each other, like compared to this one. Third scenario for solving a system is having infinite solutions. So basically, when you have the lines on top of each other, then you have infinite solutions. So it looks like this. You have line 1 going this way, and line 2 is right on top of it. Okay. All right. So let me show you some pictures, some nice pictures. And come back to that in a second. Okay, can you see the graphs?
They look like slow.
Okay, yeah, see how right here they never intersect, the red and blue? So no, so this would be a inconsistent system. Now, if you had these two, this intersection point right here, which I'm going to show you how to solve for it, the solution to the system would be 1, 4. So it would be a unique system. This would be scenario 1. Now, if the lines are on top of each other, let's say, yeah, basically the only way I could do that is to use the exact same line. So if they are the same line, then they intersect everywhere. So you have an infinite solution set, infinite set of solutions. But anyway, so that's the main idea. You're going to solve a system of two equations, and that will represent a single point. Okay, so right here, the first homework question is going to be, all right, well, here's a system. Notice how y, it's not solved for y. So you have to use different techniques. Now, there are the basic techniques that you learn, like in basic algebra, is the substitution and elimination. And then later they show you matrices. And then you can also graph them and kind of see. Graphing is, I guess, pretty easy if you have Desmos. If you have the calculator that I have, you can put this into a matrix and solve it, or you can do elimination or substitution. I think substitution is the. Let me put this back for a second. Sorry. It's probably is usually not the easiest one. I think the matrix is the best one because you just punch it in, but you have to understand how to turn it into a matrix. So I'm going to show you the elimination method once and the substitution, and then I'm going to show you how to do it with the matrix, which will make this homework really easy. But have any questions on so far? Okay. Let's move on then. All right. So this is example 1. I think in the homework, this is problem 5. So I'm going to use, I'm going to solve the same one with 2 different ways. Okay. Use elimination. So the system 2x minus y equal to 4. And you have 8x plus y equal to -9. All right, so the idea of elimination, if you've forgotten, we're going over it again, is basically choose a variable that you want to eliminate, because once you eliminate it, well, you can solve for the remaining one, right? Because if all you have is y, then you solve for y. So basically what you do, I'm going to call this 1 and 2 so we can refer to it, is you want to add the equations together and cancel a variable. You want them to be the same number, but opposite signs. Like, see how this is a negative y and a y? So if you add those together, it's going to cancel. So there's not much work to do on this one. But I'm just going to go ahead and do it. So elimination says you add these two together, 2 plus 8, negative y plus y, net 4 minus 9. Does that make sense? I have eliminated the y because negative plus y cancel. Then at that point, you just divide both sides by 10. And you solve for x. Okay. Now we'll do elimination of y over here, or of x. And yes, so x. So getting rid of x is a little harder. So we're going to go ahead and do it because that was too easy, I think, because just one step. So I want the x's to cancel when I add them together. So multiply. Remember, you can still multiply any equation by whatever you want, as long as you do to both sides and it's not 0. You'll be good. So I'm going to multiply equation 1 by -4. That way this will become a -8. And they'll be opposites, but the same number, so they will cancel. So here we go. So -4 times 2x minus y equal to -4 times 4. So this is equation 1 right there. So that will become -8x minus 4y plus the negative equal to
But why is it -4 if it says equal to 4?
what's that?
And why -4 if it says equal to 4?
I chose -4. You can choose whatever number you want, but you want to choose something that will make this the same as the other equation, the same coefficient, but opposite sign. See how I have a -8 now? So now I can just say, okay, well, -8 and 8 for the equation 2 are now going to cancel, right? See what I'm saying? -8 plus 8, gone. 4 plus 1, 5. -16 minus 9 is going to be -25, right? So now I've eliminated the x, so I can solve for y. So divide both sides by 5, and you're done. there any questions on how we found the X and the Y?
So how did you get the 8x plus y? You multiply by
That was equation 2 right there.
okay,
So I didn't mess with 2. I only changed 1.
okay.
So there's one that's after it's been changed, and then there's the original 2. Add them together.
So are we supposed to substitute after we get the answer or
No, but if you do, then you would get equality for both equations, because it's a solution to both at the same time. So visually, these two equations are going to be intersecting at -0.5 and -5. That's what we found, right? That's what we got here. So the solution to the system is -0.5, -5.
another question, is it possible to get imaginary numbers or something like that?
No, these are linear equations, and all solutions will be real. Either you'll have a single point, a unique solution, infinite solutions, or no solution. Those are the only things that you'll see.
Even if they have like a radical or something like that.
Sorry, I can't hear you. One more time. You sound far away.
Even if they have a radical.
You could have radical coefficients, but that's not going to change. It's still going to be a real number. But you're only doing linear equations, so there shouldn't be any weird quadratic stuff or imaginary. Because the name of the section is System of Linear. Okay, and so the solution what they want you to do, sorry, I kind of got ahead of myself, is determine whether each order pair is a solution. So they want you to plug it in and find out. I found the one that is a solution, which is this one, right? So the only way that all of them would work is if you have infinite solutions. So if you had the scenario 3, if none of them work, well, then that's probably scenario 2. But if you find the answer yourself, and then you can only have one, right? If the graph looks like this. But to prove it, you plug it in, and if it's not equal, then it's not a solution. It has to work for both of them. Okay. But visually, the only way to satisfy both equations at the same time is for them to intersect. So it might be worth graphing them first if you want to see it really quick. Like this guy here, number 6, is to solve the system by method of substitution. Once you solve it, you're going to find out that the answer is right in the middle, 4, 4. So let's go ahead and do substitution just so we can do it one time at least. So to do substitution, basically you solve for x or y on one of the equations. And then plug it into the other one. Okay, so equation 1 is 2x plus y equal to 12, negative x plus y equal to 0. So I'm going to take equation 2. So here's 2. I'm going to solve for y by adding the x over to the other side. So first step is isolate a variable in one of the equations. Doesn't matter which you choose. I like to choose the one that has the less amount of work. See how that was one step? Super easy. Now that we know that y is equal to x, then step 2 is take equation 1. This is step 1. Step 2. And plug in what you just found. So we get 2 times y plus y equal to 12. So right here, second step, plug in y equal to x into equation 1. So now we have 2y plus y equal to 12, 3y equals 12, so y is equal to 4. But you have to divide 3 by 3 on both sides. So I skipped one algebra step there. Does that make sense so far? How substitution works. You substitute the variable and solve for what's left. And since y is equal to x and y is 4, x is also 4. So to solve the other variable, we just plug it into, I guess, step 3. I'll make a note here. So plug it into 1 or 2, and you're going to get that x is 4. So we're going to skip that step because you can see it right there. Anyway, any questions on the substitution? Okay. So what I prefer that you do, I mean, I don't care how you do it. But what I prefer you do is just use the interesting. The matrices. So let's redo these questions by using the calculator. You guys cool on example 1 and 2?
Yes.
I don't want to spend too much time because you have done it before, but if you have questions, let me know if you have forgotten. Problem 5, using matrices. So we had the system 2x minus y equal to 4. 8x. Oh, wait, yeah, that's right. 8x plus y equal to -9. So we know what the answer is. So if you have all the x's and y's in order like this, x's first, y's first, equal to the constant, then you're ready to go. So what you create is something called a coefficient matrix. So the coefficient of the x goes down the first row. See how it's 2 and 8. Coefficients of the y's go over here. And then a little dashed line for the actual constants that they're equal to. Does that make sense? How we made it?
Is there a sign for the matrices?
A sign?
Yeah.
We use capital A for a generic matrix. The thing I need you to know is that the dimension of this matrix is row by column. So I always think of RC column, helps me remember. So I have a dimension of 2 rows by 3 columns, right? That makes sense.
Oh, we calculate that, I guess.
How do you what?
We calculated.
Yeah, just look at the rows and count them and count the columns. So there's 1, 2, 3 columns and 1, 2 rows. Okay. So now once it's in that form, you can just punch it into your machine or solver, doesn't matter. So with your calculator, all you gotta do, if you have this one, hit second math and go into the matrix menu, go to edit, pick whichever you want, and then choose the dimensions. We have 2 rows, 3 columns, right? This one straight up tells you, so there's not much to do, makes it easy. We have 2, enter. When you do a negative, make sure you use the negative button down here, not subtraction. So -1, 4, 8, 1, -9. Okay. So once you've done that, just hit quit. It's already saved in there. Go back to the matrix menu by hitting second and math. So once you're in there, you're going to want to do math inside the matrix menu. So all the math commands here are for matrices. So just go in there and choose RREF. It's called row reduced echelon form, which means it's going to solve it for you. So go press enter and then go back into the matrix menu and press enter on that first one, and it's going to solve it. And notice, just remember that this represents equations, right? So this is an x equal to -0.5. This is a y equal to 5. So if I have 2 variables that I'm looking for, then I should have a 2-dimensional matrix, a 2x2 piece here equal to some constants. And we already knew the answer because we did it with elimination, but you see how it solved it for you, right?
I got a question.
Mm-hmm.
The matrices is the same as matrix.
Yeah, matrix is a single one. Matrices is multiple. So this is a single matrix, I guess.
So I guess I cannot use the matrix for the matrices.
Yeah, it's the same thing. It's just plural.
Oh, and then my calculator says math A, math B, and math C.
Yeah, so those are if you want to make multiple matrices. But if you want to just use one, the first one is what I did.
So that would be A, I guess.
Right, I went to A and then I used the solver and went to row reduced echelon form. Oh man, I think there's a mosquito biting me. So the calculator allowed us to skip all the steps and get straight to here. Because solving this by hand it's a little annoying. It's probably like a whole page of work, which is not a big deal to me, but for you, it's a little annoying. So I recommend using this because it's much better. Because if the matrix gets any bigger, like 2 or 3 dimensions, it can be like 2 or 3 pages of work. And it just gets ridiculous.
Now our question is M times N the same as R times C.
Say that again.
Is M times N the same as R times C?
Yeah, and N by M, yeah, usually N is the rows, C is the M. Sure. Yeah, let me show it. Do you have the other calculator?
I have the Casio.
Oh, okay. Yeah, that one I'm not familiar, but I can send you some. I mean, I can send you a YouTube video if you like. Some if you can't find one, just let me know. Dang it. Okay. And there's a ton of solvers online. I don't care which one you use to save some time. Let me find one real quick for you. Oh, damn it. Here's a simple solver that's easy to use. I don't mind if I don't mind if you use it during your homework, but you have to give the dimensions, right? Or row by column. So we have 2 rows, 3 columns, set your matrix, enter your values, 2, -1, 4, 8, 1, -9. Then just solve. So we found -½ earlier and -5 using elimination. We use a calculator and there it is. No big deal, right? Where is my damn mouse? Okay. If you have this calculator, it's almost the same thing. Just want to show you real quick. Just hit second and X inverse down here. And then you go to edit. You put your dimensions. It's always row first, 3 columns. Enter your numbers. Excuse me. Enter your numbers. Yeah, 2, -1, 4, 8, 1, -9. Oh crap. Once you've input it, just hit quit. Second quit. Second X inverse. Go to math. See very similar all the way at the bottom. So you should have RREF. Go back to the matrix menu. Choose the one you made and press enter. All right. So yeah, I don't mind if you use 84, 83, 36. They're all fine. If you have a Casio and you're on your own, but I can send you some YouTube videos if you like. I'm just not familiar myself.
So what was the difference between A, B, and C? Sorry for the.
Nothing is just matrix A, matrix B, matrix C.
Oh, okay.
You can use whatever you want. Like if you need to have multiple matrices saved, you can use them. If you just need one, then just use the A. But yeah, this whole idea of systems is, I think, one of the most used topics outside of mathematics. It's very useful in almost any field, because you can create systems that are complicated, like these X, Y, Z. You can have many different variables, and they can represent real life constraints. Like let's say you have a business and you have different things going in and out of your system, and then you have a constraint of manpower. So you can have a variable constraining your manpower. Then you have a time constraint, of course. So you can have space constraints, and you can have these huge systems of like n dimensions, 10 by 10s or whatever, and you can try to find the most optimal point to
So you
allocate.
guys, sorry.
No, you're fine. It's just so you can allocate resources the best way possible. What were you gonna say?
So I guess we can do it by hand or with the calculator.
Yeah, either way. Either way. If you're gonna do this by hand, though, a matrix by hand, you would have to do row operations, which I think is not till chapter 10. So we'll hold off on showing you how to do it by hand. In section 9.1, the only by hand stuff they're asking is substitution and elimination, or just graph it. Let's go to the bottom here. Yeah, every time you Google something, you create a complex matrix, and the system is trying to solve it to find a optimal result. So the more complicated the search, the more complicated the system. What are the dimensions of rectangular tractile line here? Okay. Okay, so let's look at 11. So word problem. Let's use a system of equations to find the dimensions of the rectangle meeting the specified conditions. The perimeter is 42 inches and the width is 3/4 the length. Okay, so we're gonna have to create the equations ourselves with this information. All right. So they said the perimeter is 42. So we should know for a rectangle, 2 times the width plus 2 times the length is equal to perimeter, right?
It's still showing the screen.
Let me switch over. So that's something that you should know automatically, or if not, look it up. When they mention perimeter, you should look up perimeter for rectangle. Okay. They also said that the width is equal to 3/4 the length. Like, all right. So you can use the solver if you want, or you can just use substitution since W is already there. So plug in the perimeter. That would be 2W plus 2L equal to 42 inches. Right? If I want to put it in that form, you got to subtract the L over here. And then solve this matrix. Or you could do substitution, whatever you want for this section. So solving that system should give you the dimensions they want for both width and length. One second. All right, so let's go ahead and solve it. Use either your calculator or the website. Doesn't really matter to me. So we have the same type of dimensions. You have 2, 42, 1, negative 3/4, 0. So the best dimensions is 9/12. So width was the first one, 9. Length is the other one. So that meets the specified conditions. So that they want the width to be this particular length and the perimeter to be a total of 42. So it's like satisfying both equations at once. That's what a system does, right? So that's pretty much it for this section. Only thing I want to just mention real quick, there's a couple that are not linear and you can't solve without graphing them because of that. So basically they just want you to look at the graph and choose the solutions, right? So there's -1, 2. So that goes first. And there's 2, 4 or 2, 5, sorry. So you literally just look at the graph because that's what we said a solution means graphically. Where do they intersect? Okay. All right, well. Okay. So what I want you to do with the rest, let me see. Well, first let me check schedule before I stop. So it's 9.1. So we've basically done 91 and 92 at the same time, but I'll do a few more examples. Let me see actually before I do that.
So how many exams are left?
2 more and the final. But the next, well, I'm sorry, hold on. I don't remember. Let me check. Might mix that up with a different class. Yeah, it's 3 tests. So 1 more test and the final. Okay. 9. 2. The 9.2 is going to be the exact same thing. It's just a little bit more complicated. So, but if you're using a solver, it's going to be the same level of difficulty. If you're doing it by hand, then yeah, it's a little harder. But things I want you to see, if they're parallel, there should be no solution. If you try to solve it, you're going to get a row of zeros. You're going to get a false statement at the end. Like 2 equals 5 or 0 equals 3. If that happens on your calculator, then there's no solution. If you try to solve it by hand and you get a false statement like 0 equals 7, then there's no solution. Okay. On the calculator, if you get a row of zeros, then you have this scenario. The line is on top of the other line. So you have an infinite set of solutions. But as far as the work, actually, let me check out these real quick. I think we'll remove some of those. Got him, finally. It's a mosquito that bit me like 10 times. Very distracting. Okay. 2 planes. I'll leave one of these for you. But yeah. It's pretty much the same thing. So I'll let you work on those. I'll do a few examples next time, and then I'll start showing you how to do more details with matrices. But what I want you to do right now, because the math department is wondering why you haven't done the ISLO assignment. I want you to use the rest of the time just to get this done. If you've done it, then feel free to head out. But if you haven't, please do this right now. Okay. I'll stop the lecture and use this time for that.